Hello everyone, you are learning physics from Uncle Irodov, and in this module we will be having a look at Irodov's 1.21. Now in this problem there is a particle which starts from the origin and it moves along the plus x-axis, and the variation of its velocity along with time has been given as v is equal to v naught into 1 minus t by tau. Now before we proceed further, let us try to analyze what does this function say, v is equal to v naught into 1 minus t by tau. The analysis has been done here. As t changes, this expression inside the bracket will change, and it may become negative also at certain points of time. Now if t is less than tau, this fraction is less than 1. 1 minus this fraction will be greater than 0, and v will be greater than 0. If t is equal to tau, this fraction will become 1, 1 minus 1 will become 0, and v will become 0. If t is greater than tau, then this fraction here, t by tau, will be greater than 1. 1 minus something greater than 1 is negative, and v will become less than 0. And we know that the point where the velocity changes its sign, that is the time when the particle turns back. So in this case, we can say that the particle turns back at t is equal to tau. Next, with the help of this same velocity expression, we can find the expression for acceleration, which is dv by dt, which is v naught into minus 1 by tau, which is minus v naught by tau, which is a constant because v naught has been given to be a constant. Tau is also a constant. Further, the initial condition is at t is equal to 0, x is equal to 0. At initial time, the particle started from the origin. Now, a part here is asking you to find out the x coordinate of the particle at t is equal to 6 and 10 and 20. Now, since acceleration is a constant, to find out the displacements, we can use this expression s is equal to ut plus half at square, where the initial velocity of the particle is the velocity at t is equal to 0. If you insert t is equal to 0 here, v will be equal to v naught. So, initial velocity of the particle is v naught. Acceleration of the particle as already found is minus v naught by tau. And the values of both of these have been given. So inserting these values and the proper value of time, we will find that the displacements at t is equal to 6, t is equal to 10 and t is equal to 20 are as given. Now the B part is asking you to find out the moments of time when the particle is at a distance of 10 centimeter from the origin. So when they speak about distance, they are not interested in the direction or the side of x-axis on which the particle is. So the particle could either be at x is equal to 10 or at x is equal to minus 10. We will solve for both, and assuming the first value to be true, x has been given as 10. Solving this equation, t is either 9 or 1, and then choosing x as minus 10. T is either 11 or minus 1. This value is ignored because the values of time cannot be negative. We started observing the object only at t is equal to 0 and at all subsequent times. So minus 1 doesn't make sense. So there are 3 times when the particle is at the given distance from the origin. T is equal to 9, t is equal to 1 and t is equal to 11. Now for the C part, he is asking you the distance covered by the particle during the first 4 and 8 seconds. To find out the distance that the particle travels during the first 4 seconds, you will note that this is the time before the particle turned back. The particle turned back at t is equal to tau, which was 5 seconds. And this time 4 seconds is less than 5 seconds. So therefore, the values of distance and displacement will be exactly equal. And using the same equation, s is equal to ut plus half at square, you will find out the distance as well as the displacement. Now for t is equal to 8 seconds, it will be a bit more complicated because this time 8 seconds is greater than 5 seconds and the particle turns back at 5-second mark. Therefore, you know that the particle would have stopped, it would have turned back at a certain point, and the displacement will be lesser than the distance traveled. So let us first find the displacement up to 8 seconds. And this is done. So this is 16 centimeter. I'm drawing this on the sketch here. This is the displacement at t is equal to 8, x is equal to 16. Now where is the particle at t is equal to 5? This is the moment of turning back. So if you use s is equal to ut plus half at square for the particle will be here at t is equal to 5. So now you know that the particle starts from the origin, travels up to this point, then it turns back, and then it reaches this point back at t is equal to 8. And the distance traveled will be this entire length plus this small length here that happens to be further 9, so 34 centimeter. So I hope you have learned something from this video of mine, and I hope that you will be keeping an eye open for my future videos. See you.